Throughout history and everywhere in the world, there have been restless people who have asked the eternal question of why. The same has always been true in Latvia as well. October 14, 1862. The Riga Polytechnic University has opened its doors, the first multi-sectoral technical university in the Russian Empire. The Riga Polytechnic was established on the basis of the most modern schools of its kind in all of Europe, ones in Zurich and Karlsruhe. The new university had 6 faculties with opportunities to study engineering, chemistry, agriculture, mechanics, trade, and architecture. The name of the university has changed several times over the course of the decades, but since 1990 it has been known as the Riga Technical University. The university has been accredited by the Latvian Council on Higher Education, and it has received the praise of many international experts. Today our question is this: why? Let us talk about science, the country, and its people.
Pētnieciskais darbs ir interesants un aizraujošs. Tā rezultātā tiek izstrādātas jaunas idejas, unikāli produkti un tehnoloģijas. Es domāju, ka Latvijas nākotne ir zinātniskās pētniecības sadarbībā ar ražojošiem uzņēmumiem. Jauniešu vēlmes un iespējas veikt zinātnisko pētniecību ir milzīgas. Tāpēc darīsim to kopā, kā profesori, tā jaunie zinātnieki, un veidosim Latvijas sabiedrību.
The scientific work of the Vice Rector for Science, Latvian Academy of Sciences full member Leonīds Ribiskis, is focused on electrophysics, its practical applicability, and the automation of electrotechnologies. In an age when there is a deficit of energy resources, the issue of alternative sources of energy is important for any country's economic development. Researchers at the Institute of Industrial Electronics and Electrical Engineering work on various fuel cell projects aimed at the use of hydrogen for the production of energy. One idea is to adapt the power converters of various electronic systems for use by various users. This would apply to everything from ordinary household electronics to the power supply of electronic public transportation systems. Equally important is solar energy and the use of energy from solar panels for household needs. Efficient usage of energy resources is also important in every sector of industry, and the Institute conducts experiments here as well. Scientists are working on various aspects of the way in which electrical drive systems and high-capacity automation are controlled and regulated. They are also working on matrix-type and direct-frequency converters. A new laboratory in which specialists study manufacturing processes is the pride and joy of the Institute of Industrial Electronics and Electrical Engineering, and it is invaluable in terms of its contributions to methodological work. In any energy production process, ongoing controls are important both for reasons of productivity and of security considerations. Scientists at the Power Engineering Institute have the GTR2 system, which regulates the frequency and active power of hydro generators for use at hydroelectric power plants. The FR8 system for the control and protection of hydro generators, in turn, protects such generators against speeds that are unacceptable in a hydro turbine. Both of these systems are used successfully at the Riga hydroelectric power plant. Computers and their complex software and functions are of great importance in everyday life. The use of grid networks in the contemporary world is something that is self-evident for many people and the projects which they handle. The project called Baltic Grid was completed on April 30th, 2008. Under its auspices, the grid cluster of the Faculty of Electronics and Telecommunications was established and launched. The Communications Laboratory of the Institute of Telecommunications works on optical communications systems because data transmission speeds and volumes are increasing on a daily basis. There are different types of training programs. The efficiency of training and the related opportunities are of importance. The RTU Distance Learning Center uses modern telecommunications and multimedia equipment. Faculty members and students help to develop multimedia study materials and virtual forums for the Internet. The courses which are taught in this way were designed with financing from the FAR program and with help from experts from various European Union member states. Television broadcasts and films can also be used as an effective educational resource. Specialists at the Environmental Modeling Center work with underground water flows and their level of pollution. They evaluate underground water resources and help to come up with precise information about protected areas and pollution risks therein. The center has modeled environments which make it possible to evaluate the effects of mineral quarries, subterranean structures, and accidents on rivers. Since 1991, the Environmental Modeling Center has been involved both in local projects and in international projects in Lithuania, Russia, and Germany. Under the auspices of the European Balt Ports IT project, a modeling system for the Baltic Container Terminal was established to ensure the taking of optimal decisions at various levels of operative planning and logistics at the port where the terminal operates. 4 imitation models were established, and experimental results produced a statistical evaluation of the container terminal's operational capacities and effectiveness. Scientists at the Department of System Theory and Design are working on an autonomous robotic platform that will be used to create a prototype robot. The aim here is to create the environment in which mathematical models and management algorithms for robots can be developed and adapted. The practical results of this project will include the design of a partly autonomous robotized platform prototype that will have many different applications. In future, this will be developed into a commercial robotized platform for civilian or military use. Energy resources are all around us, we just need to find them and use them. The Institute of Mechanics studies the possibility of extracting energy from air vibrations, something that could be used in the production of electricity to private households. The social sphere has also not been forgotten. There is work on a new generation of wheelchairs which can be used to go up and down stairs. The Institute of Biomedical Engineering and Nanotechnologies works on the use of nanomaterials in medicine. Scientists are looking at ways of delivering medications to human organs so that they end up exactly where they are needed. The Faculty of Civil Engineering at the Riga Technical University has a Center for Construction Science, which brings together the researchers of all of the institutes and laboratories which operate under the auspices of the faculty. There is a water research laboratory, the only one of its kind in the Baltic states. This type of research is important at the European level, and that is why the lab is partnering with 30 institutions from all around the world in an important European project. The laboratory is developing rapid methods for the identification of pathogens, a mathematical model for the forecasting of water quality in distribution networks, and processes which optimize the purification of water. The Institute of Materials and Structures has been very active in participating in European projects. It has focused mostly on composite materials for building projects, aircraft, and ships. The Institute also seeks to optimize composite materials and constructions and to identify their mechanical properties. Specialists also study the strength and deterioration of composite materials and constructions. Improvements to manufacturing and construction have also been ensured by the researchers of the Institute of Inorganic Chemistry. The main research areas for the Institute include nano-measurement powder technologies for compounds, metals, and composites which are difficult to melt, the processing of nanoparticles into nanostructural materials, electrochemical coverings, and methods for the synthesis of internal complex compounds, borates, and phosphates. Of particular importance to the countries of the Baltic Sea Basin is the integration of landscape, ecological, architectonic, and spatial factors in the development of the Baltic seashore zone. This is the area of specialization for people at the Faculty of Architecture and Urban Planning. They are looking at ways in which landscape, architectonic, and spatial changes in the populated zones of the Baltic Sea shoreline can be changed, using planning instruments to integrate landscape-related, social, and traditional values. Institutes which are part of the Faculty of Engineering Economics are studying economic development processes in Latvia and the world. The analysis of such processes and the development of new theories are part of international projects. Doctoral students from the faculty attend a number of international events each year. The Laboratory of Management of Civil Construction and Real Estate analyzes processes in Latvia's civil engineering and real estate market. This allows specialists better to understand processes in the sector so that future mistakes can be minimized. The Riga Technical University's Aviation Institute thinks about problems with human resources, and it is working on an unmanned aircraft that could be used in many different areas. The safety of aircraft that is used intensively and for longer periods of time is a particularly important issue in aviation. The Institute has established effective partnerships with foreign specialists in this area. Scientists at the Institute of Technical Physics work with composite materials for nanostructures that are based on polymers and carbon. These are multifunctional sensors and actuators. When a certain amount of carbon nanostructures are used in a polymer matrix, the result is a nanocomposite material which can conduct electricity and offers many outstanding multifunctional sensor properties which cannot be found in polymer composites that are filled with microparticles. The sol-gel method in chemistry and material sciences has been the focus of scientific attention for more than 30 years, and specialists at the Institute of Silicate Materials are no exception. The method is used to create new inorganic, composite, and nanomaterials for optics, electronics, power supplies, optimization of heating processes, catalysis, membranes, and biochemical and biomedical applications. The Laboratory for Fuel Quality Control and Research is working on new methods for monitoring the quality of petrol and fuel which are fast and safe. Specialists are ensuring that these procedures are in line with all existing Latvian standards and EU directives. Funding from the FAR program, the EU's structural funds, and other sources has allowed the laboratory to purchase the most modern equipment that is available in studying the properties of fuel. Work at the Institute of Polymer Materials is mostly focused on new, effective, and heterogeneous polymer composite materials, and with the study of how the surfaces and boundary processes of such materials can be analyzed, regulated, and optimized. Increased attention in recent years has been focused on polymer composites, which, after use, decompose more quickly in an environment that is created specifically for that purpose. No less important are bioceramic implant materials. Someday these will be used in dentistry, orthopedics, and reconstructive surgery. The Institute of Biomechanics and Biomaterials focuses on the development and study of a variety of materials that can be used in medicine. Here, we must certainly mention work on modified arterial implants and the study of their biomechanical and morphological structure. The Institute of Textile Technologies and Design is working on an entirely new area of clothing production, clothes with a regulated microclimate, the use of semiconductor-based cooling elements in clothing, and ways of cooling down the surface of the human body. Employees of the Institute are working with colleagues in St. Petersburg on a three-dimensional fashion design system, SCAPRIM, which will make it possible to design original and tasteful apparel for a specific body. This would certainly be a new development in the fashion industry. Scientists and faculty members at the Riga Technical University are developing traditions which began 146 years ago. The qualifications of our graduates and scientists are internationally recognized. The Riga Technical University, a university which inspires. Knowledge, capability, creativity.